Good day and welcome to this episode of Applied Networks. We are going to be calculating scale reading in this episode. So this is an exam-based question, and so we should pay attention to it. Without wasting much of our time, let's read the question. So we have a 75 kilogram man standing on a spring scale in an elevator. They give us the mass of the man. So I'll just say Mn. And this is the mass of the man, and it is 75 kg. So moving on. During the first 5 seconds of motion, they've given us the time. So we write our time too as 5 seconds. So then, during the first 5 seconds of the motion from rest, and anything that is from rest, that's telling you that the velocity is from 0. So you're having your u as 0 meter per seconds. So let's move on. The tension in the hoisting cable is 9,700 Newton. So you're also given tension there, indicate it, 9,700 Newton. So what else again? Now ask us to find the reading scale in Newton during the interval and the upward velocity v in the elevator at the end of that 5 seconds. So our total mass of the elevator, the man and the scale is 860. Indicate the total mass also. M total, that's my total mass, is equals to 860 kg. Now we are using Newton's second law of motion, and what is that? The summation of force equals to the total mass and the acceleration. So what are we saying? The summation of force, we say summation F is equals to M total. Now we are dealing with all of them at once, both the summation of all the forces and the summation of all the mass. So we want to get the acceleration. So when we get the acceleration, we are now going to calculate individually for the scale reading, that is for the man specifically. So but now it is M total multiplied by acceleration. So and what if we look at what is happening here, we have two forces here. We have the tension, which is the 9,700 Newton, and we also have the mass and gravity. So when we are doing that, we are going to be having tension minus our mass in that case, then multiplied by the gravity, is equals to mass total multiplied by acceleration. We are also using mass total here also, because remember I told you we are doing the summation of all the forces, so and it will include the total. So going on from here, we are going to insert our values. We have 9,700 minus our M total is 860 multiplied by 9.81, that's our gravity, is equals to M total is 860, then multiplied by A. We are calculating for acceleration, remember. So we can make A sort of formula by saying A is equals to 9,700 minus open bracket 860 multiplied by 9.81, you all over, because this have come in, you have all over 860. So when you calculate that on our calculator, we are going to be having 1.469. So when you have 1.469, that's meter per second square. Now that you have your acceleration from the total, now you're not dealing with the scale reading now. So you're going to be using that same force is equals to MA, but this time we are doing it for the man. You know, we did it for the total here, but now we are doing it for the man. So you are going to be having T minus mass multiplied by mass multiplied by gravity is equals to mass multiplied by acceleration. This is summation of F. You know, summation of F is tension is a force there. Then the mass of the man multiplied by the gravity. This is another force. You know, this is a force. This is another force here also. So this is equals to, you know, we have summation of F also equals to MA. So that's why we have mass of man multiplied by the acceleration. That means the acceleration that we got here. So let us calculate that. We'll be having, we can make now, since we are looking for the scale reading, and it's going to be in form of, I'm sorry, this is supposed to be R. We are through with the tension here. We are calculating for the scale reading now. So we are calculating for R. So bringing this to the other side, you'll be having R is equals to MMA plus mm times g. So we can bring factorize it, we'll be having scale reading is equals to mass of man into bracket acceleration plus gravity are factorized here. So now we'll be having r is equals to, what's our mass of man? Our mass of man is 75 into bracket acceleration that we got here 1.469 multiplied then plus the gravity, which is 9.81. You calculate that, our scale reading will finally give us 845.9 845.9 Newton. It is in Newton. Remember, we are calculating force, but now it's in form of scale reading in Newton. So we have gotten our R. This is our R scale. But the second question, it said find the upward velocity. Can you calculate that using the equation of motion? And since we have v is equals to u plus at here, we can calculate velocity. So our velocity will be equals to, this is where u is valid. Remember they told us in the equation that it's from rest. So we are using u as 0 plus our acceleration here 1.469 multiplied by our time also is also valid here, 5 seconds. So v is equals to 0 plus 1.69 multiplied by 5. On our calculator we'll be having 7.35 meter per second. So that is the velocity and this is the scale reading for this part. So let's quickly move to the second part of this question. So in this second part of this question, we have been given the mass of the man again, as usual. So we have the mass of the man equals to 75 kg. Standing on the spring scale in an elevator, then now this time is 3 seconds, not 5 seconds again. So we have t as 3 seconds. Then from rest, we also have u is equals to 0 meter per second. Then in the tension t, so the tension t in the hoisting cable now is now t is equals to 8,300 Newton. This t here, that's the tension. So find the reading scale, find the scale reading rather in Newton during the interval and the upward velocity of the elevator at the end of the 3 seconds. So the total mass of the elevator and the total mass of the elevator man and the scale is 750. So we have m total is equals to 750 kg. So I want us to solve this question and send the answer to the comment section. I will just give the formulas. The formulas are going to be still the same formulas. We'll be having E of F is equals to M A. But now I think we are dealing with total. So we are going to be having the tension minus mass. The total mass is similar to the first one. It's just the same, very, very simple. So multiplied by the gravity, then m total multiplied by the acceleration. So we are using this, we get acceleration here. So when you get acceleration here, you will now come to the second formula that says the scale reading minus the mass times acceleration, that's the mass of the man this time now, multiplied by the gravity will be equals to the mass of the man multiplied by acceleration. Are you with me? So by this time now, you just make r submit to the formula. At the end of the day, you'll be having r is equals to mass of man into acceleration plus gravity. So you will have, by that time, we'll have been able to get scale reading. I'm just giving steps that you're going to use to solve it. So after that, when you get your scale reading, you can now use the equation of motion to get the velocity. Since